Hi everyone, I am Mank and welcome to this fantastic video on decision trees in machine learning by Simplilearn. If you enjoy watching these type of videos and find them interesting, subscribe to our YouTube channel as we bring the best videos daily. Also hit the bell icon to never miss any update from Simplilearn. In this video, we will discuss what is a decision tree. After that, we will see the advantages of using decision tree, then decision tree applications and how a decision tree works. At the end, we will see hands-on lab demo of how you can build a decision tree classifier. Before moving on to what the decision tree is, if you want to become an AI expert and gain handsome salary packages, look at the wide range of AI ML courses by Simplilearn in collaboration with top universities across the globe. By enrolling in any of these certification programs, you will gain expertise in skills like generative AI, prompt engineering, ChatGPT, explainable AI, machine learning algorithm, supervised and unsupervised learning, model training, and optimization. And there is much more on the list. With hands-on experience in tools like ChatGPT, DALL-E, Python CV, OpenCV, and TensorFlow, you will catch the eye of top recruiters. So what are you waiting for? Hurry up and enroll now. A year of experience is preferred to enroll in these courses. Find the course link in the description box below. With that in mind, let's get started. So what is a decision tree? A decision tree is a tree-based supervised learning method used to predict the output of a target variable. Decision tree Python can be used to solve classification and regression problems. They are frequently used to determine odds. This is an example of a simple decision tree used to classify different animals based on their features. Moving forward, let's see advantages of using decision tree. So first one is decision trees are simple to understand, interpret and visualize. The second one is they can effectively handle both numerical and categorical data. The third one is they can determine the worst, best and expected values for several scenarios. The fourth one is decision trees require little data preparation and data normalization. Moving forward, let's see some decision tree application. The first one is a decision tree determines whether an applicant will likely default on a loan. The second one is it can be used to determine the odds of an individual developing a specific disease. The third one is it can help e-commerce companies predict whether a consumer is likely to purchase a specific product or not. The fourth one is decision trees can also be used to find customer churn rate. So now let's see how does a decision tree work. Suppose there are different animals and you want to identify each animals and classify them based on their feature. We can easily accomplish this by using a decision tree. The following is a clutter sample set with a high entropy. Right? We have to determine which feature split the data so that the information gain is the highest. We can do that by splitting the data using each feature and checking the information gain that we obtain from them. The feature that returns the highest gain will be used for the first split. So we will take some following feature into consideration: color, height and the diameter. We will use the information gain method to identify which variables yields the maximum gain, which can also be used as the root node. Suppose we take color equals to yellow result in the maximum information gain. So that is what we will use for our first split at the root node. The entropy after splitting should decrease considerably. However, we still need to split the child node at the both branches to attain the entropy value equals to 0. So we will split the both nodes using the height variable, and the height is greater than 10 or height is less than 10 as our condition. So as you can see, the decision tree can now predict all the animals classes in the dataset. Moving forward, let's implement the hands-on. So this is our Jupyter notebook screen. First we will change it to decision tree. So first we will import some of the required libraries here. So I will import pandas as pd. Then I will import matplotlib.pyplot as plt. Then I will import from sklearn import matrix because we'll create matrix, and then I will import cbond as SNS. Then from sklearn.datasets import load iris, right? Okay. Oh, one more. Import numpy as np. Then I will import some from sklearn.model_selection import train underscore test underscore split. Then I will import from Simplilearn import tree, right? Let me run it. Okay. So now Pandas is a Python library that provides fast, powerful, flexible, and easy to use data analysis and manipulation tools. Whether NumPy is a Python library for Python programming language, adding support to large multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. Okay, so let's go now. Fine. Yes. And the Matplotlib. Matplotlib is a plotting library for Python programming language and its numerical mathematics extension NumPy. It provides an object-oriented API for embedding plots into application using general-purpose GUI toolkits like Tinker, WXPython, Qt, or GTK. And the Seaborn. Seaborn is a library for making statistical graphics in Python. It builds on top of Matplotlib and integrates closely with pandas and data structures. Seaborn also helps you to explore and understand your data, right? So now what I will do, I will import, I will write here iris equals to load, let's go iris, right? Okay, if I will write here iris, it will, okay, as you can see the array, you can see here, okay, iris array, right? So here I will convert the data into pandas data frame. So for that I will write data equals to pd dot data frame, or df you can write data equals to iris dot data comma columns equals to iris dot feature underscore names, right? So now moving forward, what we will do, we will create a separate column for the target variable of the iris dataset, right? So target variable will be our species. So for that I will write here data species equals to iris dot target, right? And moving forward, what I will do, I will replace the categories of the target variable with the actual name of the species. So for that I will write target equals to np dot unique iris dot target and target underscore n equals to np dot unique, then iris dot target names, right? Then I will write here target underscore directory equals to directory zip, then target comma target underscore n, right? Then data species equals to, as will be capital, data species dot replace target underscore directory, right? Let me run it. It's working fine. So now what I will do, I replace the categories of target variable with the actual names of the species, right? So now what will we do? We will separate the independent and the dependent variables of the dataset. Okay. So for that, I have to write here x equals to data dot drop columns equals to species, right? Then y equals to data species, and names underscore features equals to x dot columns, then target underscore labels equals to y dot unique. Fine. So now what we will do, we will split the dataset into training and the testing dataset, right? And we'll set some random state. Okay, so for that, before, let me add this. Okay, so here I will add x underscore train, comma x underscore test, comma y underscore train, y underscore test equals to train test split x comma y comma test size equals to 0.3 comma random state equals to 93. So what is this 0.3? What it will do, it will split the training and the testing size into 30 and the 70%. See, 0.3, 70 into 30%, right? So training will be 70% and the testing will be on the 30% of the data set, this data set. Fine. So as you can see, the class name is okay. So moving forward, what we will do, we will import the decision tree classifier class from the sklearn, right? So here from sklearn dot tree import decision tree classifier. Okay, so now what we will do, we will create an instance of a classifier class. So you can use here DTC equals to decision tree classifier max underscore depth equals to 3 comma random state equals to 93, right? So now let's fit the training data set to the model. So DTC means decision tree classifier, right? DCT dot fit x underscore train comma y underscore train. Okay, x train is not defined. Here is x train. Okay, maybe some spelling mistake. I don't think so. So it was a typo mistake. So here decision tree classifier came, right? So now let's plot the decision tree. Okay, so plt dot figure size equals to 30 comma 10 and the face color will be yellow. Let's take yellow. Later will change. Okay, then tree equals to tree dot plot underscore tree, then DTC comma feature names equals to names underscore features comma class names, then equals to target labels comma rounded equals to true, right? So let me give the font size 2 comma font size of 16. Fine, I guess 16 is fine. So now let me write plt dot show. Okay, then y underscore prediction equals to DTC dot predict x underscore test, right? Okay, t dot plot tree. Okay, here class name it is. Okay, one more error. Okay, method object is not subscript table. Okay, so here UTC capital. Again, some method object is not suitable. So it was the kernel error. So let's here find the confusion matrix. So here I will write confusion matrix equals to matrix dot confusion underscore matrix, then y underscore test y underscore prediction. Right. So here I will write matrix equals to pd dot data frame then confusion underscore matrix. Right. So here I will write access equals to plt dot access. Right. Then sns dot set font scale equals to 1.3. Then plt dot figure, then figure size equals to 10,7. Right. So now let's plot the heat maps. For that I will write heat map sns dot heat map. So matrix anot equals to true, then fmt equals to g, that comma ax equals to axis, comma cmap equals to magma. Right. So for that axis dot set underscore title, then I will write here confusion matrix. Right. Then axis dot set x label. Here I will write prediction, predicted value. Then font size equals to 10. Then axis dot set x tick value, tick labels. Then here I will write plus target labels. Right. Then axis dot set y label. Then I will write here true labels, comma font size will be 12. Axis dot set y tick labels, then it will be list of targeted values, target labels, comma rotations will be 0. Right. At the end I will write plt dot show. Okay. So let's run. So as you can see here, it created the decision tree. Right. So these are the childs and the leaf nodes. These all are the nodes, right, of the different versicolor. You can see Setosta, Virginica, right, with the different samples, okay, with the accuracy. So this is the confusion matrix of this particular graph here. You can see here the true labels and the predicted values of the particular graph, right. This is the confusion matrix. So, and with that, so we have come to end of this video on decision tree with machine learning. I hope you found it valuable and entertaining. Please ask any question about the topics covered in this video in the comment section below. Our experts will assist you in addressing your problems. Thank you for watching. Stay safe and keep learning with Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.